PEM die maker for CATIA V5 from ESI is part of the full sheet metal forming solution. It is a complete and streamlined solution for quick draw die design and is fully integrated inside the CATIA V5 environment as a dedicated workbench. It minimizes the tool designer's workload by implementing tool design and process knowledge by following the natural tool phase design process. The solution offers a set of powerful interactive tools and functions which provide guidance and support for part preparation, binder development and die addendum design. In this demo video we will illustrate the PEM die maker for CATIA V5 efficient workflow and functionalities from part definition to export to simulation for a half symmetrical double attached part. The first step in the part preparation stage is to define which regions of the part should be formed completely in the current operation and which regions of the part should be hidden as flange in order to be formed in later operations. Then as a second step, the user needs to define the part type. Both single and double attached parts are supported. In case of symmetrical double parts, the symmetrical component as well as the global and slave dipping systems will be automatically created. For the actual part preparation, several efficient functionalities are integrated to support the user in quick and easy creation of complex die surface geometries. Hole filling can be executed fully automatic or more interactively by adding internal curves to control the surface flow. Transition regions can be defined between components in case of double attached parts. Also here, internal curves can be used to control the surface flow. Part geometries can be smoothed by automatic or manual creation of smoothing curves. Open or closed ending configurations are efficiently treated with dedicated functionality. And part extensions can be used to create tangential surface extensions all around the part or on specified regions, even in case of highly curved boundaries. Of course, the user is not limited to die maker functionality alone. All available native CATIA surface commands can be used, like fill, multisection, sweep and blend. After creation, these surfaces can be added to the die maker model and be used and modified as if they would have been created with die maker functionality. Also for blank holder design, dedicated functionality has been implemented. The surface can be created via outlines, sections or fitting, or through a combination of these methods. Similar to the part preparation, also for the blank holder design, all CATIA surface operators can be used to create the required shape, no matter how complex. For building the addendum surface, the user can use specific addendum functionality, but is also free to use any of the part preparation functionalities. The first step is to define what kind of addendum will be created: outer addendum, inner addendum, part on binder, or multiple punches. The actual addendum layout will be built via parametric 2D profiles. These profiles will be positioned around the part geometry and form the connection between the part outline and the blank holder. Various predefined profiles are directly available, but in any case the user has full flexibility to create and use his own parametric profiles, store them in a database and retrieve them in X projects. The profiles will be connected through the die opening line. This line is automatically created, but if required can be modified by adding, removing or repositioning control points. After defining the global layout of the addendum via the profiles and die opening line, the addendum surface can be generated. It can be created either as a complete geometry or build up through several smaller addendum segments. Then as a last step, the die entry fillet needs to be created. Constant or variable fillet can easily be used and changed if required. Several other powerful functionalities can be used to further optimize and analyze the die face design. A solver-based trimline development functionality enables the user to locate the trimming curves on the created die face and analyze it with respect to the normal and shear trimming angles. Several functionalities are implemented to modify the part geometry itself, if this turns out to be required to improve the formability of the part. Walls can be opened, part radii can be modified, and gainers can be quickly added. Of course, drawbead centerlines are easily created, but also geometrical drawbeads are generated within few clicks. Not only one side of the draw bit can be created, but both male and female side can be considered. Finally, after completion of the die phase design model, it is important to check the feasibility of the design. A dedicated export functionality has been added to ensure a seamless link with the PEMSTEM2G simulation environment. Both geometry and process parameters like tipping information, blank thickness and press type can be exported. Inside PEMSTEM, there's a dedicated import option for die phase designs created with PEM Die Maker for CATIA V5. After import, the various groups are automatically created. Only the material data needs to be added, and in the first iteration also the punch and blank color need to be created as offset from their references through the tool builder. Next, the process must be defined. PEMSTEM2G process macros enable the user to be significantly more efficient in completion of the simulation setup. Standard macros are available from a public database and can be easily customized to meet the requirements of the part. In this example, a feasibility simulation takes no more than 3 minutes with 4 processors. PEMSTEM also makes post-processing simple and intuitive, allowing users to easily examine a variety of variables such as thinning and part quality by reference of the forming limit diagram. So in summary, PEM Die Maker for CATIA V5 from ESI offers you the speed of the natural tool phase design process while achieving high quality services. It allows you to use one single product for die phase design from the earliest phase of the development process till the final production of the part.